I'm Steve. I will explain things in just a minute. This is a website you can just go to, conversations.dora.dev. It asks a bunch of questions, which I think are interesting, and it's doing that right now, as you can see. But I'm actually going to switch slides, or switch to the slides, because that's why I'm actually here. Does it work when I push the button? Yeah, okay. So today I'm going to talk about DORA and SRE and platforms and labs. This is a joke based on a meme, based on a t-shirt. I think based on the Beatles, I'm not really sure. So if you know any of these words, you know that they're all kind of overlappy. And so hopefully we will help delineate the overlappiness of that. So this is me in black and white. This is me in color. I'm a reliability advocate. I made that job up. It's not real. Basically, I was an SRE for a long time. There's one person in the audience who's been an SRE longer than me, and maybe more, but I know of one. I won't name that person. And I work with cloud customers to talk about what SRE even is actually. I was a customer for a while. I left Google for a while and learned how to move from on-prem to cloud, and it was very, 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 very hard. So I get it. Most of the time, what I do now is I speak with cloud customers when they're building an SRE team, or they already have one and they're trying to see what they could do better about them, or they're just getting started. So there's a wide range of things that I do here. But essentially, it's the words there. I help companies to build robust, reliable systems with resilient, sustainable teams in the cloud. Wow, I got all the words in there. Lauren, did I get them all? Pretty close. Good. And I worked on a bunch of SRE stuff inside of Google. I call this etc. SRE. It was just all the other, not search, not a little bit of ads, but all the other stuff. Okay, it messed up on my screen, but it's good on this screen. Okay, so this is the recipe for today. We're going to start with a hook. We're going to go into a lecture. We're going to talk about a lab, which is kind of a weird idea. And then we're going to talk about production. So first is the hook. This is a small enough audience where we can actually do this. Whenever I ask this question in a room, I did this at SRECon where there was thousands of people in a room. And I've done it in a room with 2 people. And every time I get half and half. So let's try it. Everyone who says yes, raise your hand. Yes, you can do this. Everyone who says no, raise your hand. Not quite half and half, but not directly all yeses or all nos. Right? This is my favorite part about this question, is that it's not clear. Right? There is a discussion to be had here. A lot of the discussion is this is just a poorly phrased question. Basically, that's fine. But the point is there are actually 2 mentalities going on here. I'm going to say yes, you can build more reliable things out of less reliable things. You just have to kind of be clever about it. The example I give is RAID. So you have disks, they have less than 1/9 of availability. They break all the time, especially if you have millions of them. But you can build a SAN out of them, which has all of the 9s. Those super good, right? And you trade off with complexity, and you have to make sure that the disks don't fail at the same time. You probably shouldn't buy them all from the same vendor in the same batch, for example. They actually all fail together. That's not good. Things like that. But you can do it. You just have to engineer it a little bit. Okay. So this is what I call the pyramids of reliability. So the old model is this. Sorry, was there a question? Oh, it's echoing. Hang on. The pyramids of reliability. The old model, which is basically if you kind of naively think that if you have a 2 nines application, you need to have 3 nines backends, and means you need to have 4 nines infrastructure, which means you have 5 nines of cooling and water supply, and 6 nines of power, and right, kind of makes sense. This is intuitive. This is actually how a lot of people think the entire internet works. It's actually also wrong. So cloud looks like this. You can build more reliable things out of less reliable things. See slide 1. See the hook, right? But what it means is that you have to do more work at the top, and the work that you do at the bottom is actually less helpful. So you'll see in a second. Actually, why don't I just go forward? But a way to think about this is you can build Gmail or something that's highly available out of VMs, but the VMs do not have 5 nines. Each VM that you buy from a cloud vendor has 2.5 nines. I dare you to find a VM out in the world that is highly, highly, highly available. It does not exist. So this is why this happens. So when you move something from the old place to the new place, it falls over, right? And that's because we had assumptions on the left, and the assumptions are different on the right. And oh God, it doesn't work. Blame the cloud. You could blame the cloud. That's fine. The problem is really if your brain is on the left and your feet are on the right, you're gonna have a bad time, right? If you're thinking in the left way and you're building in an on-prem structure and you're building with all these concepts, right? That works. It's fine. It's been working for 50 years. You can keep doing that. But if you're in the cloud, don't keep your head on the left. Bring your head over to the right. You have to just change the way you're thinking. This is also why we see when things like this happen, the infrastructure teams get blamed because they can't fix the thing. And it's because of this mismatch, right? And it really sucks because the infrastructure teams get a lot of hassle because they're like, you used to be able to fix all this stuff all the time and now you can't. What's the deal? And then they're like, well, it's because you need to make the app better. I don't know what to tell you, right? We only have so many controls on this cloud thing. So it's a bummer, but it's true. Okay. Is this messing up on your side? I keep getting these weird. Okay, that's fine. So why is this happening? Basically, distributed systems happened. They didn't used to exist. They've actually been in academia for like 50 years, but they're kind of coming into like real life in the past 20, 10, 15, some of those numbers. Also, scale happened. So we have what we call warehouse scale computing. We have a lot of computers now, whereas we used to have just kind of some. Also, it's around the world. SaaS is a thing. And really just customers' expectations have changed, right? We expect things to always be running all the time. Like downtime is no longer acceptable. Please come back later, outside of our maintenance window. You see that, you're like, get out, right? Like, I want to talk to your manager. So things have changed. I'm not making this up. Like this thing, the world has changed a bit. This is kind of awesome. I just got this pointed out to me yesterday. So take a second to read this. The best part about this whole thing, you might not be able to see because it's at the bottom. This was written in 2007. So this is Jesse Robbins. You may have heard of Jesse Robbins. Started a little company called Chef, worked at a little company called Amazon. The things in color are the things you should look at. Reliable software on an unreliable platform that scales horizontally. So it's not the platform that saves the day, it's the software. Okay, now we're on to the lecture. That was the hook. I hope I have your attention. Okay, so this is you may have seen this before. SRE proclaims, we can't keep hiring operators if we want our business to scale. We can't hire them linearly to the business. So for every 100 customers, we cannot hire one operator because we have a kabillion businesses or customers, and so there's not enough operators in the world. So we need to do this thing instead called sublinear scaling. And sublinear scaling is just like the effect of SRE. I think it was actually realized later after SRE had been going for a while, like, oh, that's what we're doing, right? But it turns out it's a good idea. And how do we do it? Through automation and tooling and blah, 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 shared responsibility. Basically, go read the books on the how, but this is the effect on the business, is that the business can not be constrained by the number of operators. Like that would be bad. Like we cannot get any more business, sir, because we don't have enough people in the server room. That would be a bad problem to tell your, manager or whatever. Okay. This is another fun thing. This might ring true to you. I don't know how to make a exponential graph in slides, so this is actually just a quarter of a circle. It's not exactly an exponential curve, but you get it. But this is somewhat true, right? So the further you go along this curve, the more costly it gets, and for every dollar spent on reliability, you get less and less reliability. One way of thinking about this is every 9 you want costs 10 times as much as the last one. So basically, the farther you hill climb, the steeper it gets, and it sucks, right? So what is the kind of the thing to learn from this curve? Don't aim too high up the hill, right? If you don't need to go high up the hill, don't, right? So if someone's like, how many 9s should we have? And we're like, I don't know, all of them, right? The cost of all the 9s is all the money, right? So if you'd like to spend all of your money on non-functional requirements, go for it, but you will run out of business. So the thing that happened, though, is Google happened to be running this thing called Google Ads. And it had 3 attributes that I think are important. The first one is that seconds actually mattered. So if you remember what Google Ads is, it was a real-time ad auction business. So if Google Ads was down for 1 second, all the ads that would have been served in that second are just gone. There is no retry. It's a real-time auction, right? Also, the next thing is that this business had very high margins. Turned out to be one of the best businesses in the history of businesses. Great. So that means they could afford to hill climb a lot. And the last one is the scale also turned out to be quite huge. And so see also previous slides, it got bigger and bigger and bigger. We needed all the things. So when we talk about things at Google having like all the 9s, it's because of that. So if your business doesn't have these 3 characteristics, do not aim for the top right corner of this graph. I recommend lower. Okay, other things to kind of describe and define. Failure domains is a thing. In cloud, we talk about zones and regions. There are more, depending on the products that you're using. So if you're using a database, it's like the database or like the table, right? If you're using Kubernetes, it's like the cluster. And think of it as like a Matryoshka doll, right? So you're going to have like a region and then a zone and then a cluster, and then the cluster you're going to have like a pod, and then the pod there's like a container, and then in the container there's like process. And if any one of the outer ones fails, it takes down all the ones inside of it. So this is what failure domains are. The abstract ones in cloud, we'll just focus on those, are regions and zones. So when you're designing these systems and you want them to be more reliable, these are the things you should think about, specifically around how you're making changes to your system. So first of all, you don't want to have one failure domain. That would be bad, because if that one breaks, you're out of luck, right? Instead, you want to have more than one. And then once you have more than one, you want to only touch one at a time, right? So this is avoiding coordinated failure, right? So if you touch both of them at once and you touch them poorly, they both fall over at the same time, no good, right? That's pretty straightforward. We call this gradual change. The other thing that's a little trickier is if you touch one and it breaks, and then all of the stuff that was going to that one then breaks the other one, that's called cascading failure. That's a little bit more tricky. I don't have an exact recipe for how to avoid that, but like being aware of that as a problem is super important. So you want to apply gradual change to your system in a way that doesn't result in cascading failure. Everybody with me so far? These are all good ideas, I think. Okay. This is kind of the hot take. Stop changing tabs on me. So I want you to design for success by providing what we call exit paths, right? And then the way to remember this is I want you to run away from your problems. So when there's a problem, don't try to fix it, right? This is actually a better idea. What you're trying to do is do these running aways in a way that avoids these coordinated and cascading failures, right? You want to have failure happen within one failure domain. And there are a few ways that have been published about this. If you can't read the bottom, I apologize. There's a thing called generic mitigations. There's a link. I'll make sure that these notes get out to everybody. But basically, O'Reilly published a very small paper from a Googler named Jennifer Mace about what does it mean to do draining, spilling, rolling back, freezing, degrading, hospitalizing, upsizing, and block listing. All of these things are neat because they have nothing to do with the application or the technology or the product or anything. You can actually apply these methodologies to like all the things independently. So Macy is what we call her. She said she kept changing teams inside of Google, different products, totally different, like geo to search to maps to whatever. And she kept doing the same stuff, right? And it didn't matter what she was working on. She kept finding she was doing the same activities. So we published it. So this is a good idea. You should be able to do this. If you can't do this already, you want to think about how can we do this? How can we do spilling? How can we do degrading? Blah, blah, blah. The definitions are in the doc. I won't define them here. Okay, so when we're building all this stuff, we want to know if it's working. This is where DORA comes in. I have the shirt on and everything. Really what we care about is speed and stability. Sometimes we call this velocity and reliability. We have these 4 metrics in the DORA. So DORA is DevOps Research and Associates or something like that. It's a research program on DevOps. Basically, we do a survey of thousands of companies out in the world every year, and then we do a bunch of like math, and then we publish like, hey, this works, this doesn't. What we found, and this has been going on for 10 years. If you've read the book Accelerate, that's the same thing. So we found that these 4 measurements help predict, or they help you know if what you're doing is working or not. So the kind of the snarky line we like to say is that DORA helps you to get better at getting better. So if what you're doing to the system is actually helping or not, these numbers will tell you if it's working or not. So my suggestion is to follow this silly diagram that I totally stole from DevOps land. So you start by measuring those 4 metrics, just see how you're doing. And this is not for your whole org, but for the smallest unit of a team as you can, like one group of people that's working on a thing together. And you figure out what your bottlenecks are, what's holding you back. There's a whole bunch of capabilities on Dora.dev that you can read. If you show these to a team, they will point at one. They'll be like, this one, we are bad at this, right? You don't have to try too hard. They know what they're looking for. And then you find a capability to improve and you improve it. So that might be building some software. It might be buying a product, whatever. And then you want to enable that capability for the team and other teams, and as in the form of a product. So this is an internal product that you're providing to your customers who are developers at your company. You'll see where I'm going here in just a second. This is your platform. Make sure you gather feedback from these devs, from these customers. Like you should have a product manager, for example, right? You should have a release notes. You should have advertising, right? And then you release a version of your platform and see if it works. Then you measure those those DORA metrics again, and you just go forever and ever and ever and ever, and you never stop. This is how you make progress within your company to make sure that everybody is able to improve their velocity and their reliability. Instead of just throwing darts and being like, I don't know if it's any better, like follow this and it actually works. Keeps doing it. Okay. So the thing that you're building is a platform. This is sometimes called an IDP, internal developer platform. It's just a piece of software. It's just an abstraction in front of production. Your developers are your customers. The guy in the blue shirt, he wants to be able to, make a new service. And so he goes to some UI or he issues some command over the terminal or whatever. And the IDP just basically codifies a bunch of best practices. And these might be like best practices from your industry, or best practices coming from your cloud provider, or best practices coming from your CISO. Like we must do these things, like policies, right? So instead of the guy in the blue shirt having to know all these things, this is what we do in computer science. We provide abstractions, right? So you just push this button and get all these golden paths. This is what we call this, right? And essentially these come down to, templates and blah, 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 blah. But it's a way for these developers to build a new service that is like adherent to all the things we want to do. That's all a platform is. A joke we like to say is like, if you don't have a platform today, yes, you do. You just don't call it that. And so if your platform is like, go talk to so-and-so and they will get you the thing, you have people as a platform. And if your way to get a new piece of infrastructure is to file a ticket, you have paperwork as a platform, right? Either of these are still platforms. They're just not as cool as this one, I guess. Okay, so this is an example of an application or a product. It's made of services which run on resources in a cloud somewhere, like VMs and disks and stuff. The thing at the bottom, I hope you can see it, the green thing at the bottom is the platform. So it has like how you develop, how you do CI/CD, how you run, and how you manage things. So we're going to look at that. So we're not going to focus on the actual product being built here. We're going to focus on the other thing. So this is how you might break it down. Bunch of stuff. These are a bunch of products from Google, right? So we have Cloud Build and Artifact Registry and blah, blah, blah. You don't have to use those. You can use whatever you want, right? But you have to put a bunch of products together, and you have to use them together to get code into production so you can actually run it. The colors are, which ones are Google, which ones are not. While you're doing that, there's another abstraction that I want you to think about, and this is archetypes. So this is basically the footprint of the application that you're deploying. And if you see these columns are failure domains, specifically they're zones and regions. And so when you deploy a service, you basically get a choice. You can say, do I want to deploy in one failure domain or two or three or four or five or whatever, right? And being able to make this choice ahead of time is super important, because if I can do this effectively, I know I can perform some mitigations, right? So if I'm in two zones, I know I can handle some types of failures but not others, and maybe some tooling will help me do that. So providing these abstractions, these archetypes to your developers through that portal allows them to make good choices, right? It helps them be able to not just pick random places to deploy their software, but follow a pattern. Here's one of them. This is our old friend hot cold, right? Active passive zones. That's all this is. So there's a bunch of describers here. The cost is double because you have to run two of the things. It can only survive a zone failure, not a regional failure, right? The complexity is really low. This is really easy. This is actually very good for software that you don't have the source code to, right? If it's just software you just want to deploy twice, maybe you only want to, maybe you have to pay per license or something like that. This is a very effective way to make something, just a little bit more reliable. So if one isn't good enough, the answer is, get another one, right? Pretty straightforward. This is how you would do it on Google, an example. The numbers are theoretical. You can definitely do worse than this, but the ceiling of your SLO in a system like this is basically 3 and a bit nines, so 99.98%. That's pretty good, right? You probably don't need that much more than that for a piece of off-the-shelf software. Having two turns out hot cold pretty good. It gets more complicated. Here's the rest of them. There's documents online that show this more. The one on the far right is the global one. That's the Google Borg model, essentially. It's run it in all the places all the time. It is expensive, but you can be highly available from it. You can also run different archetypes on the same infrastructure. So you don't need different setups for each of these. So this is one pool of 6 clusters running in 6 different zones across 2 regions. And I can run one service globally, one multi-zonally, one active passive, right? So I can make these choices ahead of time because I know The one on the far right's not that important. It's as low on that curve. I don't want to spend that much money because if it's down, it's not a big deal. But the one on the left is the thing that makes us money. So I want to spend all the money on it. I want to deploy it globally, and maybe it's like highly latency sensitive or something like that. Again, this curve, right? You can follow this curve for each service that you deploy. And what I'm suggesting here is that instead of having a continuous curve of every choice ever, you make it discrete, right? You quantize the curve, you give them 5 choices through your platform, and you say, pick one, right? And if it's the wrong one, they can just change it, right? So how do we do this in real life? We use a lab to learn how to do this. So this is a thing I made up. It is a place to play around. So when I give you this lecture, you're like, oh, that sounds great, but like I got a production to run here, buddy. I'm not just gonna like mess with it. The idea here is like we want to give you a place to try these things out. So we built an MVP of a platform, and it's free and everything. I call it RAP because acronyms. It's called the Reliable App Platforms thing. I don't know. So it's an MVP of a platform. It's really, really basic. I'm not super. It is not a product. I could not charge any money for this. But it has basic CI/CD. It has these ideas of archetypes. It's running multi-cluster, so you can have things running in different places. It's got some basic observability. You can just use it. You can spin it up. There's a bunch of Terraform. It costs $50 a day to run because it's running a bunch of infrastructure in a bunch of places. So like, be advised, it is not free, right? It costs money on the cloud. This is what it looks like. These are a bunch of screenshots with a bunch of like labels on it. So like, it's real. It works. If you see this one with the colors down here, this is this thing called Hipster Shop or microservices demo. What we've done is we've run it in a way so like some services in this app are running dual zone, some are running single zone, some are running globally or multi-regionally, just to show that you can do it. We have a fun little demo where we run this and then we like, take out a cluster. You'd be like, oh, the cluster fell over. What do we do? And like, turns out the app is still running, right? Because we have SLOs, we can see like it survived. It's great. So how do we put this into production? Once we've tested things in the lab and we're like, this is fun, we should totally do it. One thing that's important is you don't need to have every app and every product and every service on the same platform right away, right? You can introduce them like slowly. Also, you can work with people, right? You can give them carrots, not sticks, and you can suggest, the people who are ready to try something out, you guys go first and see how it works and have them be your early customers, right? Please do not set an adoption OKR, right? Like we're going to have 45% of production by the end of the year. Bad plan. Like this is bad incentives, especially not at the very beginning. Do not waterfall this. You're not gonna guess the future correctly. Turns out. So this is like a silly example of how it might work. It's like over time you're going to introduce capabilities to your platform. I just made some up. It takes a while to build them each in, so they follow this little pattern. This is the platform itself. You build this. And then separately, you introduce services. So they get adopted onto your platform. They were running on something else before. Now they're running on your thing. Start with the low risk ones, please. I was at a place where we built this and then we put the billing platform or the billing service on it right away and it all fell over. It was really bad. Don't do that. Like, do not put the important one on first. That's the example you don't do, right? If the thing needs like dual region and it's not ready yet, it's going to fall over and you're not going to be happy. So instead, just push it back. Let it wait a bit. So get confidence in your capabilities before you adopt them for your important stuff. I think this is the last slide. Okay, parting shots. So get better at getting better. Start with DORA metrics. Make sure that it's working. Define SLOs at your front door if you're just getting started. Don't measure deep in your system first. Start at the top. Start where the customers are. Know if the system is working or not. Apply gradual change through failure domains. Build capabilities through your platforms. There's this concept of SRE adjacency. Kyle, I know I've said this in the past and I didn't define it very well, but basically it's the idea of like, if a team gets a bunch of SREs to build some stuff for them, make sure that they share that with other teams too, right? You don't have to have SREs on your team to benefit from having SREs next door, right? If you share these tools, you share this platform with everybody else, we all win. Make sure you practice in the lab. And of course, focus on learning and writing things down, right? So if you have a problem, you have a failure, learn from it, learn about your system, write your retro, write design docs, etc. That's it. I spoke so fast. Okay, I think that's it. These are more links about DORA.
All right, where do we start? Who's got a question? How do you select DORA metrics? Maybe you can give an example.
So the DORA metrics are stable. There's 4 DORA metrics. How you implement them is specific to your product. So like, how often you deploy is pretty straightforward conceptually. But if you have 7 ways of deploying, you have to implement it 7 different times, right? And you have to bubble it up to a report to your leadership or to yourselves or whatever in 7 different ways. And so the work is actually in the tying the metric to the concept. So there is a project on GitHub called 4 Keys. It is freely available. It has a bunch of examples, has a bunch of implementations. You will never get it right out of the box where it just works. You have to work at it a bit. There's also the idea of time to failure. And so how do you measure that? It's very important. I know we just talked about MTTB or MTTF and MTBF before. It's really important that you don't over-index on these numbers when you have like a strong diversity of outages. MTTR is actually only good for a bunch of a distribution of things that are self-similar. If all your outages are different from each other, having the mean of those like gives you nothing. You're just losing a bunch of data. So only come up with these numbers, these statistics on very similar events. And also, frankly, if you're having a bunch of outages that are all the same, you have other problems, right? Like don't really bother with those statistics or don't put too much credence into them. I know that it's in the DORA metrics. We've actually changed it to not be just mean time between any failures, but specifically mean time between failed rollouts. So specifically, how long does it take you to recover from a failed rollout, which is essentially how fast is your rollback. And that is something you can actually measure and you can actually improve on and so forth. I hope that answered your question.
Just wait a sec so that we record your question.
Steve, I love your work on application archetypes. I mean, feels like it's filling a badly needed hole in the industry. I'm curious, in your experience, have you seen that thinking get adopted by people who are new to Kubernetes, or is that generally like, hey, we've been at it 4 or 5 years and we've seen some of the problems?
I think it's so this actually, I have to give credit where it's due. Anna Berenberg and Brad Calder wrote a paper in the ACM that actually defined this stuff. I just took it and made it into slides, basically. But it's useful, right? And it's also on cloud.google.com. It's a lot easier to read than the paper is very dense, but it's very good. You should read it. I've seen teams use it that have a dedicated platforms team that have tried a bunch of ad hoc stuff over time. And they're like, this is too much. Like, there's too many choices. We want to just simplify things. And then so snapping to these 5 points, like they didn't know what to snap to. When we showed them this talk, they're like, those are good. We're going to use those. I've also seen teams who are just getting started and they're just adopting this from the beginning. So I think both can work, but it has been, so specifically we had at the last Cloud Next, we had ANZ, which is a big bank down in Australia, New Zealand. They're using it directly and they're building it into their system and it's working quite well for them. So I know it is useful. It's not just theoretical. So I want more people to try it though. Tell me if it works for you.
Hey, Steve. So how do you convince leadership to keep funding these sorts? So these things take time, right? So like, right. So after an incident, there's some initial like, okay, we're going to fund this, but like, how do you convince them to keep funding it over time to get it like all the way over the finish line? Like what patterns have you seen that actually work?
Yeah. The thing that actually seems to be important is to like come at it from 2 directions, right? So having a bottoms up and a top down seems to be kind of the only way that really works, which is having a team which is like motivated to do these best practices or these good ways of working or whatever, but also having someone who is in the leadership circle who can vouch for them, right? So the joke we have is like you need to have a chief reliability officer. Probably don't call them that, right? Like that's probably a bad idea. Because reliability is everybody's problem. It shouldn't be one person, whatever. Okay. You probably shouldn't have a CISO either, but you all do. So who knows? But like having someone who can represent the reliability efforts to like the board and like, the CTO and like the people who are signing the checks to say like, no, actually, this is pretty important. Like we need to stick with it is super, super important. Apart from that, the DORA work is actually pretty good too in terms of being able to relate the fact that you're attaining high velocity and high reliability actually results in good what we call business outcomes, which basically means makes money. It's shorthand in the business world. So the 2 outcomes that we measure in DORA are does it make money and are people happy? And doing this stuff like makes both of those numbers go up. And this is why we do these surveys. You're going to have questions about causation versus correlation. This is something else in the middle, right? This is predictivity. Right, so we can say that teams who do these things it predicts that they have this outcome. Is it causal? Kind of. But like over and over again, we see this prediction come true and come true and come true. And people who don't do them, it goes the other way, right? So if you are mean to your employees, turns out they quit. And it turns out also if your system is unreliable, your customers quit too. So you don't make money. So you do need to have leadership who can listen to data. That's important. So having that person in the room to do that translation is very helpful. It is still an open question. I don't have a perfect answer for you.